Welcome back to AutoTechNick, and today we're starting our second video in the series of videos on this 1995 Ferrari F355 that came all the way from Houston, Texas to Seattle, Washington for its major service. As you guys can see, we have the engine and drivetrain out of the car, and today we're going to be tearing into it. We're going to be pulling this engine down, getting the timing belts replaced, getting the new timing belts put on, taking care of our camshaft timing. I'm sure we're going to be doing a lot of other great stuff on this engine, so get comfortable because we're going to dive right on into it. Gotta love the track brake pads. Yeah, I think that clutch is slipping. Get this thing out with some freedom. Now, if you guys missed our first video featuring this 355, you're definitely going to want to jump in the playlist and check it out, because this is one of the most unique 355s that I've seen in my entire career. And this whole car, it's a vibe, and I am absolutely here for it. Obviously, it's a striking green, but this car actually is originally a yellow 355, and it has a vinyl wrap on it. But it also has some key features that we can't really see because the car is disassembled, so you're missing the whole vibe that we have of the car. That's why you guys got to go back to the other video and check it out. Because if you look in here, yep, this car has a roll bar in it. And what you really can't see is this car has the factory Ferrari Challenge rear spoiler on the engine deck lid back here. If we look at the engine, or the drivetrain, it has Challenge coilovers on it. So this car sits extremely low to the ground. It has the Challenge front brakes. And one of my favorite parts right here, the car is equipped with the factory Ferrari Challenge speed lines in white, which I do love, and even have the stickers matching the wrap. So this car is a definite vibe, very different than most 355s that you see. And this car isn't just for looks. Its past history in life pretty much spent its entire life on the track. It was just a personal toy for a gentleman that just loved having track days. And that's why, honestly, it's why it has the wrap. Because if you see a car that spent a lot of time on the track, the paint job takes a lot of wear and tear and abuse, essentially. So the paint on this car, from what I'm told, is in pretty rough shape. That's why they ended up putting the wrap on it. But you know what? I'm here for it. I love it. This car is just the absolute perfect track rat. I love 355s and this whole vibe of the car. It's a combination that I never would have thought up in my head beforehand, but then once I got the pictures from the client when he first sent them to me, I I was in love. I absolutely love this car, the whole vibe of it. Yeah, it's a car you can take out and drive hard, and you don't have to feel bad about it. You don't have to worry about where you park it. You don't have to worry about someone leaning up against it. So it's like you get all the best benefits of owning a Ferrari and an F355, and you don't have all the stress and headache that comes along with it. So that's a perfect combination. So with that, last video, we talked about the car in a little bit of detail. We did our road test on the car, which we had it wasn't that great of a road test, guys. I mean, it's hard to complain about getting the opportunity to drive a 355, one of my all-time favorite Ferraris, but this one wasn't running very good. The clutch was absolutely slipping. It had several issues that we're going to need to get sorted out. That's the purpose of the road test, right? We need to get it out on the road. We need to evaluate it so when we're doing this work, we know what we're looking for. What we're going to be doing today is we're actually going to be moving on into our major service. So we're going to be pulling our intake plenums off. I need to get the valve covers off, our ancillary belts off, cam covers off, timing belts. I'm just going to get as far as I can. I've already done my compression test on the engine. It's very healthy, very consistent. We did a leak down test in the last video. I know this engine's already had valve guides replaced, but we still went through, did our checks. They're very healthy. Smoke tested the exhaust manifold, so they're good and healthy. I even smoke tested the plenum, made sure there's no leaks for ITBs and from our plenums themselves. Everything is good. So I know mechanically this engine is in great condition. Everything is healthy. That gives us the A-OK to move in and start doing this belt service. Now, since it wasn't too long ago, we had that 99 F355 that was on or in the shop, and I did a series. I think I did like almost 10 videos on that car. We're going to film this one a little bit differently because on that car, we really went nuts and bolts. I really walked you guys through in a lot of detail on how to do everything on the car. And really a lot of what I'm going to be doing on this car today is essentially the same. So my goal here really is I'm just going to set you guys down. I'm going to work through as much of this as I can. I'm going to bring you guys back periodically so we can discuss either findings I found on this car, things to keep an eye out for, or anything that's different. So it's not going to be as much of a play-by-play as our last series of videos, but still a lot of great content, and that's what we're jumping into. With that being said, my goal today, I want to get as far as I can. I want to get my pre-service cam timing checked. I'd love to have the timing belts off the engine, but the only way I'm going to do that is set you guys down and get started on the engine. So without further ado, let's start diving into it. right, some status updates on our 355 teardown. I would say for the most part, things went pretty much as expected. But when I say as expected, you have to keep in mind that this is a 30-year-old car. There's a lot of heat back there, so I expect to find things along the way, and we absolutely found a few things along the way. So let me drop you guys in and show you what we have. You can see that I started getting the plenums off. We got all of our ancillary belts off, the belt covers removed, even got all the way down to the valve covers, and I was actually really pleased to see how clean everything is inside the engine. But like I mentioned, we know this car has had valve guides, so I would expect to find that clean. We get back here behind the belt covers, you can see that it is not clean at all. It is very gross, and that is why I actually gave myself a bit of a head start and pressure washed off this drivetrain before we got started. But we have the plenums off, we have our fuel rails and injectors out, and I also, you might see, I took the alternator out because that needs some repair work, and we'll talk about that in a second, but that you do not need to take out for the service. So I have that off for now, and also if we spin you around from the back, I ended up taking our test pipes off because we're going to be replacing those during the service as well, and I took the starter out because that, along with the alternator, are going to get rebuilt and repaired. So I got those items out of the way for now, got all that taken care of, and I'm trying to remember all the things that I kind of came across when I was disassembling this that are big talking points. One of the things I mentioned, it's an old car, right? So the age, a lot of the plastic and a lot of the rubber, it really starts to show its age, especially in the back of these cars with the heat after all these years. On our vacuum lines, you can see right there, this vacuum line starting to crack and split. I expect to see that. I keep bulk vacuum hose here on hand. Essentially, cars at this age, I'm just going to go through and replace all this vacuum line right here, both sides. I'm just going to, everything new, up here to where our fuel pressure regulator feeds into. In between our ITBs, there's a small section there. Replace every piece of vacuum hose on this engine. There's no reason not to while we're here. And our vacuum check valves, replace these during your belt service. When these fail and stick open, it'll cause a loss of vacuum supply to your reservoir. It'll not allow it to retain that vacuum, which will affect your secondary air operation and your exhaust bypass valve. That's why I keep them on hand. If you guys look, show you guys what a new one looks like. You can see even through the bag that it looks pretty nice and it's good. And these ones are probably the worst I've ever seen. Look how just old and beat these are. So these are not even an item I test and check that are good. I just replace them with every belt service. So when we're doing all the vacuum lines, I'm going to replace those, get those taken care of. Back here are cam sensors on both sides. You can actually see right here in the connector that part of the plastic from that cam sensor broke off and is stuck in the connector. As this side, you can see it's all the way open. So I'll bring you guys over to my bench. And I saw when I was taking this apart, I actually saw that this cam sensor here was cracked, and I took pictures. But then when I pulled the connector off of the other cam sensor, you can see what I have right there. So that plastic just completely crumbled, disintegrated, and broke. So that, I've seen that several times. It's not a huge deal. We'll just replace both cam sensors, but it's just one of those things to keep an eye on disassembly. We have here our vent hose for a fuel tank purge. And this has a T right down there, you can see right there, and that obviously broke. So this is a really hard plastic line. I'm gonna have to see if I can heat this up, or I can probably drill out that plastic T and get that out without damaging this hard plastic here, and do the same thing on both pieces, and then just get a generic T or Y fitting, get that in there, and that way we can save the majority of this line, because really it was just this plastic T that's failed. But we got to get that taken care of. Another weird thing, this was the first time I've ever had this happen. A dowel pin right here, which sits right there for the valve cover. You can see that one buried in the head. When I pulled the valve cover off, this dowel came out, which I know they come out, and I take them out when I send my heads to the machine shop, but it actually ended up falling down in the head, down in that cavity down there, and I saw it. Obviously, I was able to get it out with a magnet. But I've never had that happen. I've had them pop out on me, but I've never had it just pop out and fall into the engine. And I kind of want to take a second and talk about all these things that we just spoke about, because it's a 30-year-old car and it's tempting to just move through the disassembly very quickly on these cars. But I actually try to take my time and go slowly because it allows me to catch and notice stuff like that. But also, I'm not just tearing the engine down and taking it apart. I'm just inspecting everything and kind of looking and observing and really evaluating everything, because it's one of those things where the more you kind of look and study it, you start finding and noticing other things that are just deteriorating with age. And some of these items are so cheap and easy to fix, it's a no-brainer to address. If it's a more expensive item, we'll just talk to the client and have that conversation if he wants to address it now or when it fails. But it's not as straightforward as a newer car where you can just take it apart, replace what you're replacing, and put it back together. You have to be slow. You have to be methodical. I shouldn't say you have to. You're going to have a lot better results if you're slow, you're methodical, you're inspecting parts, you're being very intentional with what you do. You're looking at all the areas around the part that you're removing and just inspecting everything. So there's a lot of that I do. And I will say on this car, I actually went and got everything torn down. And then once I have everything removed, I actually have good access where I go through and I spend a fair amount of time just looking everything over, inspecting everything, and looking for other problems that I might not see so we can catch them now. The entire point of all of that is to catch them now while we're servicing the car, and we can be proactive. And I want any repair that we're doing to these cars to be proactive, where we can address it now, and not reactive, where the car develops an issue when the client has it and he's driving it. That's my entire goal during these services, is to do our best at catching anything. I'll bring you guys back to the bench. I had another weird one that I've never seen. And that's when I pulled the oil tank off. Our mounting flange has broken off right there. And this sits, show you on our subframe. It's the only thing that the oil tank sits on. It sits on that little pin right there. And then we just have our hoses that connect to the oil tank, and then the bolts at the top that mount the oil tank to the chassis. This is broken off. You can see it's bent and deformed. I'll talk to the client and see if he wants me to go through. I'll have to clean this oil tank up, which welding this is going to be a nightmare because it's aluminum. I need to TIG weld it, and TIG welding cleanliness is the key to welding. And this thing is just saturated and soaked with oil, which is going to make it tough. But I'll talk to him and see if he wants me to spend the time to straighten this out, get that welded back on, maybe build some reinforcements for it so it's a little bit stronger, and get that taken care of. There also was another broken ear on this pipe here, our secondary air pipe on disassembly. You can see right there, that guy's broken. So maybe I'll take care of both of them at the same time. But just little things like that you got to pay attention to. You know, these rubber hoses on this crankcase vent line that went to the valve covers, they're just so hard and old and deteriorated. You need to replace those with new ones. Our other oil lines, they were cracking. We knew that. That wasn't a surprise on disassembly. And I'll say on our valve covers, you can see here just how dirty they actually were. But on our valve covers, there's no modifications made, which I expect to find, meaning these corners are factory. They're not beveled. There's no stakes punched into it. There's no chamfer there where our O-rings go in. And like I mentioned, more often than not, I pull a car apart and none of those modifications have been made. So once we get everything cleaned up and the belt's off, we're going to have to come through. We're going to have to chamfer and bevel our edges. We're going to put our punches here on the heads to hold our gaskets in place. And speaking of our gaskets, valve cover gaskets or cam cover gaskets on this car. These gaskets were so old, they are actually very saturated with oil, and they're starting to split in the center. This engine had a significant amount of oil and grime on it, but it all started from the cam covers down. There's really, the only other leak sources that this engine could be leaking from is from a head gasket, which is not likely at all. The oil drain tubes on the sides of the head, which they weren't leaking. So it's really, if it was the cam covers leaking, it's going to go all the way down the engine and make it look a lot worse. I say this because there's always this big debate on how often you need to be servicing a 355. The factory says every 3 years. Some people say 5, some people say 10. Everyone has their different opinion on when a 355 should have timing belts replaced. I'm going to tell you guys my opinion on 355 timing belt replacement intervals. Now we know the factory recommends every 3 years. I generally recommend to my clients to do this timing belt service every 3 years, no longer than every 5 if they want to stretch it. Obviously, I talk to them, it's a risk versus reward if they're comfortable stretching the service out to 5. Now, if they are just purchasing the car or the car is new to them, I definitely recommend having it gone through and a service so that way they know, you know, this condition of the car, they know where it's at, they know that everything is good. It's a good known point. If the car is unknown, it's hard to say. So, I mean, if the car just had a service done, let's wait the 3 years and then you go through and do that service. But if you had a car that had a service done, you know, 2 years ago or 3 years ago, and you're not sure who did it or really the level that that service was done to, maybe consider doing that service then. But there's one thing that I think everyone focuses on the timing belt service interval, and that is the timing belts themselves. Sure, timing belts, yeah, they're probably fine after 3 or 5 years. Absolutely. I do not disagree with that whatsoever. But there's a lot of other components in this engine that people aren't considering, which I think those are the main reasons why you want to reduce your service intervals so that way you can get in there and get them inspected and replaced. One of those items, tensioner bearings. These belts are very tight. You want to be sure your tensioner bearings are good, because if this tensioner bearing goes, obviously you lose a belt, you lose an engine. That's a big deal. Those tensioner bearings aren't going to last forever. They're not lubricated. They are greased and have seals, but you can't really refresh that grease and relubricate them, so you want to get them out and get them replaced. These engines create a lot of heat. They're also flat plane crank, which has more vibrations, so there's more vibrations going on in them as opposed to a regular engine. But really, the big thing that I want to talk about, and it really applies to this car, is our cam seals. So our front cam seals back here, and these O-rings, and our valve cover gaskets. Now this kind of deviates into two subjects, because the first subject is everyone knows what a belt service is on a 355, the getting timing belts replaced. But everyone's belt service is very different. I bet you the majority of people that are doing timing belt services on 355s are not removing the valve covers. And if you don't remove the valve cover, you cannot replace these O-rings, you cannot replace these cam seals. You can put new belts on it and new tensioners, but you can't do the rest of these items. So for one, if you're getting a belt service done, do know what you're getting replaced, because also that has a big factor on what you're paying for a service, if you're getting a good deal or not. Whole nother subject. But what I'm trying to get at here is, by getting our timing belts done here, say every 3 to 5 years, and by doing it where we're going to pull the valve covers, we're going to be degreeing our camshafts, I always replace all of these seals up here. That lets us refresh all of these seals. When I pulled the valve covers off this engine, these seals here, the lower paper gasket for our valve cover, was so saturated in oil that it was actually splitting in the center of the seal. So I saw that recently on actually this 456 behind me when we took apart that car and took the intake manifold off. But you can actually see right here that's split completely, and it's just completely coming apart right in the center. Actually, I can probably tear it all the way. You can see that. That intake manifold gasket was so saturated, it was actually splitting in the center and getting wide. And we had the same thing here on our valve cover gaskets or cam cover gaskets. And with the amount of oil that was leaking on this engine, that had been a problem for a while. So it's one of those things where it's kind of a different opinion. Some people are only referring to the timing belt service as the integrity of the timing belts, and if they should go through, have this service done to replace the timing belts. I view it as an overall package that you're doing. So you're doing the timing belts, but it's more so by doing that service at a quicker interval, the way I am doing the service where you're pulling the valve covers off. That's given me the opportunity to go through and not only put in new timing belts, get new tensioner bearings in there, check the integrity of our hydraulic tensioners. I replace the front crankshaft seal. I replace our 4 cam seals back here, which if we take you to this side, look how dirty that is. You could clearly see that that's been leaking back there. I'm gonna replace all of these O-rings here, all of our spark plug O-rings, all of our back gaskets, cam sensor gaskets, valve covers. So there's all those parts that are gonna get replaced. So that way, if you keep up on that, the car is not gonna leak oil, because let's be honest, the valve cover gasket design is terrible and it's not gonna last forever. No matter how good you seal it up, no matter if you do all the modifications to bevel the edges and make your stake marks and do everything, use the right sealants, and you do everything perfect, they're still not gonna last forever and they're gonna leak. So basically my point of view is you get the car in, you do your belt service, and it gives me an opportunity to go through. I'm gonna basically it's like a reset, right? Get all of our new seals in. I'm gonna have my hands and eyes on everything. I'm gonna make sure everything's where it needs to be. We're doing our inspection, which is a big part of my major service. So before I even started pulling the engine out of the car, we did a compression test. We did our smoke test on our exhaust manifolds, scanned the car for faults. What else did I end up doing? You know, we're doing all of our checks essentially. So we're checking our flywheel, we're checking our catalytic converters if the car has them. There's all these other things that I'm doing that I do on every single service. I almost spend an entire day test driving the car and inspecting the car and doing all my checks before I actually end up getting into the work of the belt service. And by doing that periodically, that helps keep the car in a great running condition. It helps you be proactive so you're not surprised by any repairs. And you can keep up on these things before they get really bad and become a problem. So let's say, case in point, if this car had what I would refer to as a belt slap, where they left the engine in the car, they removed the fuel tank, removed our front timing belt covers, and did their belt jobs. They would put new timing belts on the car, new tensioner bearings, left the valve covers on. Yep, the car would have had a belt service. It also would have had that broken oil tank mount that they probably would not have found. It would still have all of the oil leaks from the cam covers. It would have the broken cam sensors at the back of the engine, which, although the car was running fine when I got it, it was only a matter of time before that was going to break further. Moisture is going to get in there, and there's going to lose a cam sensor. You're going to have a problem. So you can see that by us getting this apart and just having our hands and eyes on there, it really helps you be proactive, which in my eyes, yes, there is the expense of the service, but it enhances the ownership experience, because I think most people rather be proactive and fix those items before they fail and leave them stranded on the road or ruin a driving event that they're in with the car. So that's my ramble on 355 major services and service intervals. I'm probably think it's a topic that's worth a separate video at some point where we can go in more detail on that. I just wanted to show you that basically I spent the time, we disassembled this engine. I found a lot of other things. There's a few other things I found too that we knew, like our timing covers are cracked. There's some missing hardware. There was just a lot of things that we need to get sorted through on this engine. I'll probably cover those as we go through and fix them, correct them, and repair them. But that's really the biggest advantage that I think a lot of people don't take into consideration when they're talking about a timing belt service. It's not just about the timing belts. It's not just about the tensioner bearings. In my eyes, it's almost about everything else around those items. And obviously, since we're here, I'm not going to reuse old timing belts or tensioner bearings, so those get replaced as well. With that, guys, the next step that I actually need to take care of is I need to measure my belt tension for my timing belts before I remove them. And then I'm going to check where the camshaft timing is actually at as the car was delivered to me. And then once I have that documented for all 4 camshafts, then I'm going to go and remove our timing belts, our tensioners, and I can get the cam seal plates out. And that will mark the point where I have the engine essentially as disassembled as it's going to get for this service. Where I'm at time-wise today, I think I can get that done today. Today's my Friday, meaning I'll get that done today. That's going to give me the weekend to go through and just have a normal weekend. Then I'll come out here next week and I can start all my cleanup, my modifications, and start walking you guys through the process to degree in the camshafts and get everything. I really want to cover more of the assembly on detail than the disassembly in detail. I will quickly show you guys what I have planned here. You can see I have my own balancer that I drilled and tapped the bolts on rather than using the customer's balancer. So I need to get this removed, mine installed. You want to have a balancer still installed when you check your camshaft timing, because the drive gear on the crank snout is a helical gear. This balancer holds that gear in place. So if you take the balancer off and you have your degree wheel mounted to the crank snout, that gear can walk forward, which is going to change all of your camshaft timing. You won't have true honest numbers. I got my degree wheel, I bolt onto my balancer. I kind of have a little socket set up that I get installed in there for the crank bolt. So I'm going to get all that set up. We're going to use our TDC gauge so that way we can check where we're at on TDC with our piston travel. This piston travel gauge right here, I essentially use to calibrate my degree wheel. We have the pointers from our last 355. If you guys do these jobs frequently, save them. It saves you a little bit of time. So we're going to get our pointers set up. We're going to get our dial indicator right here set up on our camshaft. And the key to having this be as easy as possible for you is use a little 90-degree foot that we use out of our dial indicator here. That makes it a lot easier to get that on the lifter bucket, work around the camshaft. I'm going to just basically take the rest of today, get all that stuff put on, get it just work through real quick. This is only a reference check, so I'm not making any timing adjustments. I just want to see where the camshaft timing was when the engine arrived. It gives me a good idea of how the car was serviced last time, and also gives me a good idea, a reference point on how the car was running. So if we drove the car beforehand, we had a slipping clutch, and there's various other items I found on the car that affect how well it ran. And this one, I wouldn't say was running great when we drove it, but this just gives us more information to look back on from our initial test drive to be like, oh, you know what, our cam timing was radically out. That's probably another reason why the car wasn't running great. Or if we have a car that's not running great and the cam timing's dead nuts on, it kind of makes me think maybe I should look around a little bit more and make sure everything else is okay, because essentially by checking where the cam timing is at now, it gives me a known variable. I knew how the car ran when it came in. I knew where the cam timing was at. And also, it's just a good reference point for when I put everything back together, although we will check and make any necessary changes on camshaft timing. So I see a lot of people that dive right in, just pull the belts off and don't check it. If it's your first time doing a belt service and you've never degreed camshafts in on a Ferrari, it's great practice. Might as well just go through it and do it that way so you can help get your brain wrapped around it. Then when you're actually doing it, once you have everything disassembled and reassembled, you have a little bit more confidence in yourself. Really, my goal here today is I'm just gonna work through all that stuff, get my cam set, get the timing checked, get it documented, and get everything torn down so I'll get the belts off. Then I'm probably just gonna call it a day. And then I'll come out here next week. I'm probably gonna just start off right away, getting everything cleaned up, spend some time with some brake clean, get my gaskets cleaned up, and get everything prepped and ready for reassembly. Then I'll bring you guys back and we'll start covering all that in more detail. So I'm gonna get to work and I'll see you guys back out here next week. We're back, and I have a lot of things to update you guys on with the status of our engine. Made a lot of great progress last week and this week, and really things are looking pretty good. So let's jump in and see where we're at. And you'll notice immediately it already is a little unusual because I have one belt off and one belt on. And where I left off last week, I was talking about how I was going to run through, check my cam timing, and my goal was to get it torn all the way down and have the belts off and have that be my stopping point of the week. And that's exactly where we made it. So I've already got everything cleaned up, prepped, and I've already went and installed our new belt on bank 2 over here, our new tensioner, all of our new seals. So I'm kind of at the midpoint of reassembly. I have not done anything over here to bank 1, so I just kind of show you a couple things before it all goes back together. Now let's talk about our camshaft timing when we took this thing apart. Bank 1 was looking pretty good. I think I was 1.5 or 1 degrees off on the intake cam. And the other one was one cam was 1 degree off, the other one was 1.5 degrees off from factory specs. So that's really close, real tight. Things look pretty good. Now over here on bank 2, again, I think it was 4 degrees off on the exhaust cam and 3 degrees off on the intake cam. So these were quite a ways out of spec, and the range that Ferrari gives us is the specific degree plus or minus 1 degree. So there's really a 3 degree range in total. You have your target number you want, 1 degree above, 1 degree below. So when I'm mentioning that that camshaft is 3 degrees and 4 degrees out, that's meaning it's 4 degrees away from the target number. So definitely not ideal over here on bank 2. And my belt tension was also quite a bit looser on bank 2 than it was on bank 1. Both belt tensions were far below the factory specs. We only were doing that for reference and documentation. It really has no bearing on our reassembly, except it gives us a known starting point, because you'll notice that I do mark where my dowel pin goes on my camshaft, so I know that that is the hole where my dowel pin goes on my cam gear. And you can see right here that the cam gears themselves are also marked and then I mark them with a Sharpie, so that way I can get each specific cam gear back onto the right camshaft. I can get the dowel pin in the same hole in the cam gear and the camshaft. So theoretically, my camshaft timing is going to be right where it was when we left off, although it might change a little bit with the new belt and having it set at the proper tension. So you can see over here, the gears we haven't put on yet, my marks. And I will say that a couple of these dowel pins were actually had pretty good burrs on the sides of them. Not on this, it was on bank 2. Bank 1's pretty free. But I actually had to hammer them out of the cam gears. They would not slide in there free. Like you can see, the slides in there pretty free. So that's pretty normal when they get installed under tension and really just forced in through the cam gear and the camshaft. It mars up the sides of those dowel pins, and that makes getting them back out when you're making your camshaft adjustments an absolute nightmare. Whoever was doing this last was a little aggressive and probably used the washer and the bolt right here to force those dowel pins in, and that's what happens rather than not having tension on it and getting it to slide in by hand. So for the dowel pins that had the damage, I just took a file and I was able to file them and get them cleaned up so that way they slid in and out smoothly and effortlessly, so we were able to save the dowel pins. However, I do keep dowel pins on hand just in case I encounter stuff like that mid-job where I don't have to stop and order more. Luckily, I was able to save these. Now, for cleanup, pretty straightforward. We go through, we clean off all of our gaskets. I just use a straight razor blade to scrape it off. And then I like to use red Scotch-Brite with a little WD-40, or sometimes even if the oil is still on here. And I scrub the rails down. That gets any of the old silicone out, gets everything cleaned up, makes it very nice. We have to do back here where our gaskets were for our cam sensors and get all that cleaned up, all of that taken care of. That's all done, that's all cleaned, and some key talking points over here that I did some modifications on. You can see these 3 punch marks I put right here on the rail of the head. This is where the valve cover gasket sits, this paper gasket. And you can see our stud back here is the furthest clamping point that it has, and they have a tendency to slide out right here. That is one very big common source of oil leak. So the gasket pushes out, and then you have a gap, and they just leak a lot of oil like this car had done. So I go through and I do those punch marks with an automatic punch. You just push down. I do 3 punch marks per spot. You can probably see, like right there, my nail's getting stuck on it. The whole goal is it creates a raised spot on the surface of the head, and then that gets pressed into the gasket and helps kind of just bite into the gasket and keep it in place. So if we look back here on the back, did the same thing up there and on the top. So you can see I do it on all 4 corners of the outer rail gaskets. These pieces are so small, we don't need them. We don't need them back there, and there's really not many issues in the center of the rail, so we just need to be strategic where we place them. Now, the other modification we make, which might be harder to see, is this corner right there, this leading edge corner. That's a good view right there. You can see I've gone through and actually filed that down and got rid of that sharp 90-degree edge. Now, on this car, on the heads, they were filed down. Actually, no, the valve covers were filed down a little bit, but the heads were not filed down at all. So someone kind of did the repair, but I like to file the heads and go through and do the valve covers as well. And we do that because those sharp 90-degree edges will come in and bite on this O-ring and cause that O-ring to get torn and damaged. And that's right where our paper gasket connects to this O-ring. So it's kind of twofold. We could have this gasket slide out if we don't have those punch marks. And if we don't file those edges, this O-ring is going to get pinched and we're going to be leaking a lot of oil. It's a very common thing on the belt-driven Ferraris. They all essentially use the same sealing system up here. Like I said, this stuff really, it does a lot of favors in the long run. It helps minimizing the gaskets from sliding out, help preventing leaks, help preventing damage to those O-rings. So that's what I really go through and do. Go through and get everything cleaned up, make my modifications here to the head. I file those edges over here. Now we have to do the same thing. It'd be hard to show you back here, but where there's O-rings back here and a solid aluminum plate that slides in to seal this section. So we have to bevel where that O-ring goes there too, so it doesn't get damaged. Back up to the bench on our valve covers. Again, I make that bevel on that edge. I make the same stake marks here on the valve cover. Same thing back here, and then you can see right there, we beveled those edges, and that is all to prevent damage to these O-rings. So, and these are new O-rings. These are brand new cam seals. So this is what I was talking about, where a lot of people, where they do just a belt slap, they're not replacing these items. And these are the rear plates as well, so we don't damage those O-rings. You can see As just mentioned previously, all the old O-rings that are on our cam seal plates, putting in all new camshaft O-rings, the rear O-rings, even a new crankshaft seal. These are the cam sensor O-rings. Old tensioners, these are the factory style tensioner. I prefer to use the Hill tensioner, it's much better. Really, a lot of time cleaning things up. I spent a lot of time going through and making those modifications. I take my time so it looks nice. I want it to look as factory as it is, even though it's not factory. Generally, I'm not a big fan of making modifications or deviating from factory on these engines, but those punch marks in the rails, they're really just a necessity. It really helps those gaskets stay in place in the long run. So we got all that taken care of, and you can see on this side that allows me to get everything reassembled. Now, I will say that on these cam seal plates, you might see a little bit sticking out, but for the bottom that sits in the head, it is actually sealed with that 3-bond 1211, which we'll do another layer up here on top when the valve cover goes on. So you can just see some of it barely sneaking out there. So those are sealed up. They're bolted on right here from the front. And since this car is at early 95, we actually have to go through and make sure we have clearance for the newer style tensioner bearings. Fortunately, this car was already modified because it's running the newer style tensioner bearings, but you want to make sure that you have clearance right here because the bearing is going to interfere on that gap depending on where it's adjusted at. Now, I did end up taking both of these brackets off. This bushing was pretty gummed up and seized up. It didn't rotate very freely here, which would affect our ability to get an accurate belt tension. So when I had this off, I just went and cleaned these up a little bit more because it just wasn't really that attractive, and just made sure that we had enough clearance there. And I was able to, with this off the car or the engine, I was able to put the bearing on and make sure that it has a full sweep without interfering and touching. And then obviously I cleaned everything up, got all the old sticky grease out, and you can see that these move very nice. And it's gonna help us have a much more consistent belt tension here. So you can see we have our pin in. This side, the pin's loose, this belt's tight, but since I have the cams locked down, you can see there's way too much slack on this run of the belt. So that's just set there for now. And this side's really ready for reassembly. I need to get my tensioner on, my cam seal plates up here installed, my cam gears installed, this other belt installed. That's gonna allow me, once the other belt's in, come back, take my business cards out of my camshaft so that way they can spin. Do that on both sides. This side's still locked down. Once I can rotate the engine over a couple of revolutions, again, we'll put the crank pulley on. Once I can rotate it a couple of revolutions, that's going to equalize the slack or the tension in all the runs of the belt. It's going to let me work to start setting the belt tension and work through that process. So we're getting ahead of ourselves. There's plenty I need to do before we can get to that point. What I'm going to do is I'm going to go ahead and just get this bank one belt on, cam gears, tensioner, cam seal plates, get all that put on, get our pulley put on, and also get our business cards out of the camshafts. And I'll bring you guys back when we're ready to start tensioning these timing belts. So we have the cam seals and plates on bank one installed, our cam gears are installed, timing belt, tensioner, everything is installed and ready to go. Now before we start talking about setting the timing belt tension, I want to say that we're just going to be glossing over everything today. I'm not going to be doing a deep dive like we did on our last 355 belt service. So everything on this side, like I mentioned, is installed. I have the business cards out of the cams on both sides. You can see I threw my crank pulley on just so it's easier to rotate everything over. I will say, the way my setup works with my degree wheel, once I bolt this onto the crank pulley, I'm able to put my socket on the nut and the spacer, and it holds everything in place, and it basically lets me just keep the ratchet on the engine without it falling off. That's why I'm putting the degree wheel on now. You don't need the degree wheel on to do what we're doing. I'm just doing that because it's easy for me tooling wise. But we have all of our business cards out of the engine, so it's free to spin. You can see like I have a lot of slack right here on the belt. That's why we're going to rotate the engine over 2 revolutions in between each time we make any changes to our belt tension. You can see I have this pin right here that's loose, which is one indication of how we check for correct tension. This other side, same thing. But again, I know my belt tension's not right because I should not be able to do that at all. Once I rotate this engine, we'll take that slack out. That's going to change our position for our tensioner. Everything's going to change, and we're going to have to go through and check our tension. For checking our timing belt tension, I like to do it in the same engine position every time, which is top dead center, compression, cylinder 1. To ensure that I'm going to be able to be very precise with this, I'm going to just install my TDC travel gauge right now. So this is the Hill engineering gauge. This is the adapter that's going to go in our spark plug hole right over here for cylinder 1. So I'm going to get that threaded in and tightened down. And then we're going to install our dial gauge into that hole and that adapter tool, and that's going to let me watch our piston travel on cylinder 1. So I'm doing that for 2 reasons. One, as we just mentioned, it's going to let me put the engine pretty much exactly at top dead center compression cylinder 1 every time. So the engine's in the exact same rotation or same position when we check our belt tension. You have to keep in mind that we have the valve springs pushing on the cam lobes, whether the cam's on the opening ramp or closing ramp, and that's going to have an effect on which direction the camshaft's going to want to rotate, which has an effect on your belt tension. So if we put the engine in the exact same position, we're consistent. The second reason is when we're degreeing in or calibrating our pointers on our degree wheel, we're going to be relying on the TDC gauge for a piston. And really, when we're calibrating those pointers, I'm trying to eliminate the dwell. It's very easy to put our TDC gauge in and measure and find the top dead center point of the piston, but the piston actually has a dwell period where the crankshaft is rotating, but the piston's really not moving. So the rod for the crankshaft or the piston is kind of coming up over the top dead center and then starting to fall down. Meaning the piston's going to come up, hit top dead center. The piston itself is going to sit stationary for a couple degrees of crankshaft rotation. As the throw of the rod comes over the top dead center and starts to fall, then the piston comes down. So it's easy to identify when the piston stops and calibrate our TDC gauge, but I'm picky, I'm fussy, and when I degree or calibrate my pointers on my degree wheel, I want to have them calibrated exactly considering the middle point of that piston travel, meaning I'm not so much worried when the piston's exactly at top dead center. I want the crank throw exactly at top dead center. So by installing the TDC gauge now, as I'm running through and rotating the engine to get our belt tension set, I can actually fine tune the face of the gauge, get that dialed in to 0 as close as I can, and it's just going to speed up when we get our degree wheel installed and our pointers and go to calibrate that. I'm going to get my tooling installed on the engine real quick, then I'm going to rotate it 2 revolutions so it's back on top dead center compression number 1. Then I'll bring your eyes back so we can start talking about how to check and correct our timing belt tension. All right, our tooling is installed. I've rotated the engine over 2 revolutions and stopped at top dead center. So you can see this is what I'm talking about. As we rotate the engine over, I can watch for the maximum needle movement here, and then I can rotate my gauge face to make sure that it's as close as I can get to the 0 point. It doesn't account for a dwell, but the more precise I am to start with, the quicker it's going to go here and the more precise we are once we get our pointers on the degree wheel and we get those calibrated. Now you can also see what I was talking about, how it has my sockets and everything in there, just kind of wedged in, so I can just leave my ratchet there. It's pretty convenient, works out pretty good. And what do we have after we rotated this twice? Well, you can see both of these pins now are too tight where they're kind of wedged up in here and they don't rotate freely like they're supposed to. So we're going to have to make some adjustments to our timing belt tension, but before I do so, I wanted to do a quick high-level overview of the different ways to check and verify timing belt tension on a 355. This is one of those subjects in the other series of videos that I went into a lot of detail on. We talked about the different methods. I ran you guys through the procedures really in depth on the other series of videos. I'll link it up here if you want to check those out. For today, we're not going that far in depth, but we're going to do a quick crash course. Factory 355 workshop manual says to adjust these tensioners right here so that way these pins rotate freely in the bore. This is our hydraulic tensioner, and this pin is going through the piston of the tensioner that's pushing up on the bracket and our tensioner bearing here. You can see the tensioner bearing is offset where the bolt hole is from the center, and these 2 holes here give us access for our special tool right here. So we can rotate this tensioner, and by rotating this tensioner right here is how we can remove or add tension to our timing belt. Now, just like from when we first started, how I had a bunch of slack up here and now I don't, I've made no changes to the timing belt. I've only rotated the engine. Anytime we make a change here, we need to rotate the engine twice. I usually let it sit for a couple minutes, let it settle, because these belts kind of tend to stretch out a little bit, and I want the hydraulic tensioner to settle. So I'll rotate it 2 revolutions, come back, let it settle, and you can recheck these pins and make sure that they're there good and tight. Now, I have these pins in because we had the belts off, and I use them to keep the tensioners in position. I'll tell you that I do not use this pin method to set my timing belt tension. However, I do leave my pins in till the very last minute because it is a good, quick, easy visual if I'm right on my tension. Now, let's go to the bench and we can talk about some of the other ways. Basically, on setting timing belt tension, this pin method on this hydraulic tensioner is like the first version of how Ferrari gave us the spec to set tension. The second generation or method they gave us is the Stager gauge right here, where we can put this on and we're physically going to measure the deflection of the belt. These gauges are, I'm not sure if they're built anymore or made. They are hard to find and they are expensive even used. These things are several $100s, pushing $1,000 used. And you got to have a calibration bar with them as well. A lot of Porsches and Volvos use these. I have it. I don't use it that frequently. It's not really my go-to tool. I only use it when it's my only option. The most current version that Ferrari has to set timing belt tension is right here, and this is with a frequency gauge. This is an optical frequency gauge, and a lot of the ones, actually the one we used at the dealer during my time there was a audio one or a microphone. So there's different versions. I can tell you that this is by far the most consistent and nicest one that I've ever used, but we're going to jump back to that video that I talked about where we did the deep dive on the other 355. I went through each version of how we went and measured the timing belt tension with the pin. I even talk about how we can cross-reference from a 360, and there's a gap that you can measure here. That's more information that we can piecemeal together. In the end, I talked about that this is the easiest version, not version, but method to use, and it's easiest for the home do-it-yourselfer because in that video, I downloaded the Gates Tension Right app on my phone. I use an iPhone and just used the microphone in my phone and checked the belt tension, and I checked it with this gauge, and this is a several $1,000 gauge. And they were dead nuts on the same. So all of us at home have a smartphone and the app is free. So you can download that app, use your phone, check your tension. That is going to be the most precise. And I like it because it's the most tangible, repeatable number that you can use. And it's also the quickest and easy and most definitive to measure the belt as you're checking your tensions. So use the app on your phone. If you have access to a nice gauge, use that gauge. But the frequency method is the best. So you can see we have this zeroed out. And this is what I like about the optical gauge is it's very easy to get a reading, even one-handed. So you can see I'm 120 hertz. And see, you can show you guys, it just takes barely a flick with my hand. And also note that as I'm talking, there's no change in this gauge. That was one of the problems that we had with the gauge that we had at the dealership. As I mentioned, it had a microphone. We found that if you had a smart electronic charger on the car, that the electronics on the charger actually created a frequency that this gauge or the gauge that we had would pick up. Or if you had a V12 running in the back of the shop, it would pick that up and start to have, your readings would bounce around quite a bit. So we'd have to wait, or basically wait till someone was done running a car or unplug the battery chargers before you get a belt tension reading. So it was a lot harder to be consistent. That's the benefit of the optical. I never, at the dealership, used the phone app to know how that would work. I was only testing the other video. But just keep in mind that other things can affect the reading, what you're picking up. So if you're getting something erratic or it's really jumping around without you hitting the belt, then you need to kind of reevaluate and try to find that source to eliminate it. We have 120 hertz on bank 1. Bank 2, it's 106, 105. And you can see I'm barely moving the belt. And I can tell you that the ones that I've used with the microphones, sometimes it was frustrating. You really have to work the belt to try to get it to read. So I'm grateful that I have this one now. But what I will do is I'm going to spare you the process. I'm going to go through and set the timing belt tension. It's really a lot of wash, rinse, repeat from what I just did. Both belts need to be tighter, so I'm going to loosen my tensioner bearings. I'm going to rotate them into the belt a little bit. I'm going to rotate the engine 2 revolutions, let it rest and settle, check my belt tension, 2 revolutions, and I'm just going to basically wash, rinse, repeat the same procedure until I have both belts tensioned in between the 190 to 220 hertz. Try to get both belts as close to one another as I can. This process can either take a couple minutes or it can take a long time to get them dialed in. It just really depends. And I will say that if you start having something that you're really struggling with, like you can't get a consistent reading on one, let's say it was too tight, you tighten it more than it reads too loose, you have something funky, that's where you need to start really paying attention to your hydraulic tensioners, if they're good, and also this pivot point, if that grease is there and getting sticky. I took care of those, so we know they're good. These tensioners, I have service history in this car. They're pretty new, so I'm not too worried about them. I'm not questioning them. But this is the time where it shows up if you have a bad tensioner. You're going to have some really erratic, unusual behavior trying to set your belt tension. So I'm going to take note of the time here. It is 2:07. I'm going to hunker down. I'm going to start working the tension of these belts. I'll bring you guys back, and we'll see how long this ended up taking me. Yeah, like I said, 2:07. We'll see if we get this done pretty quick or if this is going to take a little bit of time. So we'll see you guys back here in a minute. So, what's the damage? It is now 3:35. So that was an hour and a half to get our timing belt tension set, which I would say is not unusual. Here's how it went for me, which in itself really isn't unusual. Bank 2. I had bank 2 set right on spec, we're about 215 hertz total, which I need to add. I misspoke earlier, and when I was talking about setting the tension and measuring it, we measure off of this long run here, but also the short run there. We add those two numbers up. The sum of those two numbers is our tension that we want, which is 190 to 220 hertz. Back to bank 2. About 20 minutes in, nailed it. We are it was right at about 215 hertz. I was like, this is good. I only made like 2 or 3 adjustments. I spent all my time on bank 1, just fussing with it, just dancing back and forth, back and forth. It's real finicky, especially if you want to be very precise with it. Eventually got it set. That one's just a skosh tighter, right at the top of spec. That one's pretty much right at 219 hertz. Now you can see we left the pins in and they're both loose. So that's just a good spot check. And I leave them there during the repairs. And I also haven't torqued these bolts yet. That's what I do at the very end of the repairs. I'll torque these bolts. I make sure my pins still are free to move, and I'll even recheck my tension. But I do that because we might have to pull the belts off during a cam timing phase. You can see that I put this on, ignore that. I have the pointers on, ignore that. I only did those because I was just bored while I was sitting and waiting for the belts to relax after I'd make an adjustment. After that hour and a half, I'd just going crazy. I even went as far as to put the power steering pump belt on and tension that because I was just looking for stuff to do. I was just trying to be efficient with my time. It's just years and years of doing this where time mattered. It's just kind of like a habit. It's just idle time. I'm going to find other stuff to do so I can make this project move on quicker. Our belts are tensioned. We're all set. We have this gauge, as dialed in as we could get by just eyeballing it. And as I mentioned, I have my pointer set up. You can see that I have it lined up right here. This is going to be our bank 1 pointer. And I have it lined up the best I can to the 0 degree mark. And our bank 2 pointer right over here, right on 90 degree. Again, I just eyeballed them. Nothing's calibrated yet. And that's the next thing we need to take care of, is calibrating these pointers to this degree wheel. We use our TDC gauge to do it. Again, reference back to the other videos. I did this in great detail. Essentially is what I'm going to do. I'm going to measure the piston travel with our TDC gauge. I'm going to measure the piston on its up travel, and we're going to pick an arbitrary number. I always pick 0.5 millimeter from top dead center on this gauge, so it's going to be our big needle down at the 50 down here. That right there equates on our degree wheel to 8.5 degrees. So is what I want to see is I want to see at 0.5 millimeter on my TDC gauge, 8.5 degrees both times on the degree wheel. If I get that, that tells me that my TDC gauge itself is calibrated and my pointers on my degree wheel are calibrated. I've mentioned this before. I'm going to focus purely on just calibrating this one on our 0 degree mark. Bank 2, I'll eyeball it for its 90 degree mark once I have this one set. And then once we move our tooling over and work on bank 2, our 0 mark will be over here because this is a 90 degree V8. I'll recheck with that calibration, but it's really just a spot check. I'll also probably go through and show you, because I always say it's a arbitrary number, this 0.5 millimeter. So I might go and just do 1 full millimeter and we'll see what number that equates to on the degree wheel. It's a pretty simple process. Just keep in mind any adjustment I make to my pointer will have an effect on what I'm doing with my dial gauge. Any change I make with my dial gauge is going to affect my pointer. We're basically going to be fine-tuning and calibrating the pointer and degree wheel and that gauge at the same time. We're essentially using the two gauges to dial both of them in at the same time. I will set you guys down with the camera. I'll try to give you a good view. We're going to rotate this through, get this calibrated real quick so that way we can move into our camshaft timing checks. Alright, so we got all of our tooling set up. I hope you guys have a good view. You can see my pointer is right here, right on our 0 mark. We have our gauge that you guys can see. Just for reference, right down here at just a little bit before the 6 o'clock position is our 0.5 millimeter mark. The needle is just a little bit before my 0 mark up there. So this is all just eyeballed, nothing's ran through and calibrated. The only caveat I'm going to give you guys right now is we need to be sure that we're checking this TDC gauge on the same engine cycle every time. That's because this is in the #1 spark plug hole, meaning the cylinder is sealed up. It does let a little bit of air out of here, but we do build a little bit of compression when we rotate the engine over. You will hear the air coming out of it. That's important to note because that little bit of compression we build, you will see that in this gauge because this gauge has so much fidelity. As we build a little bit of that compression, it actually pushes down on our rod bearing clearance since we have no oil pressure, and it will change your reading on this gauge if you're trying to calibrate it on top dead center compression, and then you try to recalibrate it on overlap, and then you rotate it again and calibrate it on compression. You'll be chasing your tail forever. So all that means for us is we need to rotate the crankshaft 2 times every time we check this gauge and calibrate it. We just basically need to ignore the reading of this gauge when it's on overlap because it's an inaccurate reading. Really splitting hairs here, but it's just the way I like to do it. So we have everything here. It's on compression. Our gauge is pretty close to 0. This is pretty close to 0. The first thing I'm going to do is I'm just going to rotate the engine over. So we drop it down to 0.5 millimeter right here. And we're going to then move our eye to the degree wheel and see what degree we're at. I know once it's fully calibrated, 8.5 degrees is what we want. I don't know what we're going to get right now. So the needle moved up and now it's starting to drop. So that tells us we're not set up and calibrated just yet. And bring it down. It's hard to do this without overshooting it. And I'm kind of off to the angle because of the camera here. And right there at 0.5 millimeter, I'm keeping steady pressure on my crankshaft. And that shows me right at 11 degrees on our crankshaft. So we're looking for 8.5. We're going to go, before we make any change to our pointer or our TDC gauge up here at the top, we're going to rotate the engine around 2 revolutions, and we're going to measure it on basically the piston up travel. We just measured it as the piston was coming down from top dead center. Now we're going to catch the measurement on its way up. So again, this is overlap. We're ignoring that. And I'm watching my degree wheel right now, and I'm just keeping an eye to when we get to about 20 to 15 degrees before top dead center. And then that's when I shift my attention to my TDC gauge. So we're right here at 15 degrees. I haven't talked about it, but the smaller needle right here, I kept note of where that's at, which is really right about 45 in between my 4.5 and my 5. That tells me when I'm on top dead center, so I know that I actually need to rotate probably 2 revolutions of this bigger needle before we're there. Just one thing to note so that way we don't overshoot things. So we're going to see, we're going to bring it around. Yeah, there we go. And then as we bring this up to 0.5 millimeter here, and this is showing about 6.5 degrees on our degree wheel. So you can definitely tell that we're biased with this pointer, where this pointer here is biased in that direction, but we don't know if our TDC gauge is actually properly calibrated because that can have an effect. The pointer could be right, it could be all this gauge. So now I'm going to bring this around and I'm watching my TDC gauge as it's getting close to 0. And we're going to check here at a degree wheel, it's right at about 0. And now you can see the gauge went up past 0 a little bit, and we're way off here with our pointers. So for one, I'm going to make this change to tighten that gauge up a little bit. And I'm also going to come up here and get this pointer reset to 0. So we're just making gross changes right now. So we got that set. It's going to be the same thing. I'm going to go and rotate 0.5 millimeter on this gauge, check our degree wheel, and see what we have. And the pistons should be moving down now. The needle did not move up initially, which is good. We're coming down on our down travel. And now on a degree wheel, we're at 9.5 degrees. So that's a lot closer. We're only a degree off here. So let's rotate 2 revolutions. We'll catch the piston on its up travel and see where we're at. Eyes go up to our TDC gauge. We got 1 full revolution. Come around. Half a millimeter. Just about 8 degrees. So we are close. Going to rotate this crank. Watching the TDC gauge. Comes up to 0. Just about to hit 0. And we're kind of overshooting on our degree wheel here past 0 a little bit, but this needle's starting to hit the dwell. So I'm going to make my change on our pointer. To be just a skosh past the 0 point. Right there. And we'll go to 0.5 millimeter. And we're at 9 degrees. We'll go 2 revolutions. And watching the TDC gauge. And that one's right at about 8.5 degrees, which is good. Bring this up to our 0 point. Watching our TDC gauge, it stopped. We're at about 0. Our pointer degree wheel is right at about 0. We're going to take it to 0.5 millimeter. Just a hair before 9 degrees. So I'm probably just going to tweak this pointer just a little. So I got that tweaked. The pointer's sitting right at about 8.5. We should be set. We're going to rotate it around and double check. I like where our TDC gauge is at. It's giving me a consistent number that I trust. So we're right at about 10. So I'm watching my TDC gauge. Just about 8.5 degrees. I have a little bit of tension on it again. Let's just see what it does when we go up to top dead center. So we're all zeroed out here. So 0.5 millimeter. Well, it's 8.5 degrees. That's what we're looking for. We're looking for this 8.5 degrees on the up travel and down travel. And that tells us that we basically are measuring the same center point, which is true top dead center with this gauge at 0. So we're pretty well calibrated. Now, I always keep saying this is an arbitrary number, this 0.5 millimeter. So if we're at 0.5 millimeter now, let's say you wanted to use a full millimeter, which would be right there. That was 1 full revolution of the needle. That's about 12 degrees on the crankshaft. We can verify that, where if we want to spin this around, coming up, now right here at 15, I'm going to watch the needle and stop at 0, right there, and you can see that we're 12 degrees here. That's just proving my point that the number that you pick on your TDC gauge is an arbitrary number. You just need to pick one reference point where you're measuring the piston stopping in its travel on its way up and its way down. Whatever number you pick here will give you a different number on your degree wheel, but we could do the same thing with 12. You know, we're measuring 12 before top dead center, 12 after top dead center. If we have the same measurement with this pointer on the way up on this gauge and the way down on this gauge, that means our 0 mark is dead center of those two numbers on both gauges, and we're set and calibrated. Here's where we're at. Timing belts tensioned. Degree wheel calibrated. TDC gauge calibrated. Now we're ready to move into our camshaft timing checks. I have my dial indicator set up over here on the intake camshaft of bank 1. And if you look, I have my pointer rod coming down. You need to measure on either the forwardmost or front valve or the rear one. Center valve camshaft profile is retarded by 10 degrees. You will not be able to get your camshafts degreed in measuring off of that. It's hard to see in there. See if I can get you guys zoomed in. But I have my pointer sitting on the lifter bucket. You can see that I have my stanchion right here bolted onto the cylinder head. And it just has all my tooling set up. We are on top dead center, compression, zeroed out on that gauge. So what we're going to do is we're going to rotate this to top dead center overlap. And I should be measuring the bucket or the lifter travel. It should be 2.41 millimeters. That's what we're looking for in this. So it's again, it's kind of Ferrari's way. It's a bit of an arbitrary number. We're not doing it in the conventional manner where we're measuring the intake opening and closing of the cam shafts. They give us specific measurements and callouts. Now, I will say there is one thing that I have done differently on this one versus the last 355 where we did the camshaft timing. Again, I'll reference that car a lot in these videos because they're a lot more in depth than what I have planned to do here. On that car, I assembled everything with these washers right here that hold those dowel pins. You can see that washer overhangs. There's a flat in that washer, actually right here, that holds the dowel pins in location. And I did talk about in that video that you take these bolts out, you have your belts tensioned so much that these cam gears kind of shift. They'll pop and they kind of get pulled forward and separate from the camshaft right here. which makes it very difficult to get the dowel pins in and out. Probably how these dowel pins got boogered up that I talked about earlier, because someone let that gear flop and they just tried to force that dowel pin in. If you notice, I have different washers that I drilled the holes out that allow me to bolt the cam gear in, but I have full access to my dowel pins right there. Now, I didn't do this on the last car because the tools that I usually use to get the dowel pin out is a pair of pliers like this. But when I was working at the dealer, there was actually another technician that had a pair of pliers that is what I actually would always borrow, and that's why I have those washers that I made, and I'd use those pliers. I didn't have them here for the last cam belt job I did, so I couldn't use that method, so I couldn't show you. Those pliers are right here, and they're vampire. These little vampire pliers. But if you look at the end, they have a rounded kind of tooth. It's like these little guys were made to grab onto those dowel pins. These are pretty inexpensive. I think they're under 20 bucks. You can buy them on Amazon, and they work fantastic, where I can get them in there and I can get on that dowel pin. With these washers, all I have to do is just loosen this 19mm nut a little bit. That just takes a little bit of tension off of the cam gear to the camshaft. And I can get in here at these and just gently grab that dowel pin. The cam gear is not going to wedge itself onto the camshaft from the timing belt. I could pull it out, move it to my hole, and make my change. So much better. It makes this job so much quicker because I'm not pulling these bolts all the way in and out, in and out. And you can see I have them on both sides. It's a lot better. I've used this method before. It works great. I don't have enough washers. I need to make more so I can do both banks at the same time. But that's what I have. And then when I'm done, I'll come back and put the factory stuff back on. Plus, we have to replace those O-rings anyways. So I just wanted to show you guys that trick. That's what is different here. It's going to just allow this to go a little bit quicker. So again, we're on top dead center compression. Going to rotate to overlap. We should read 2.41 millimeters. I'm going to get this rotated. I'll bring you guys back and we'll see where this camshaft timing comes in at. This was pretty close on disassembly. Hopefully it's there again. All right, so here we are on top dead center overlap. We had our gauge zeroed out at top dead center compression. Now we're on overlap and it's reading 2.19 millimeters. Ignore the negative mark. That does not matter at all to what we're doing. And I said we're looking for 2.41. Now, in the factory workshop manual, there's a chart that shows you your numerical values that you get here at the camshaft and how many degrees on the crankshaft that is, so we know how far out we are. Because right now we know that we're not in spec, but we don't know by how far. Easier way versus looking at the factory workshop manual is I'll just rotate the crankshaft until I get 2.41 millimeters on that gauge. Then I'll read here on the degree wheel, and that tells me right there how many degrees out we are. So we will be able to know if we're within our 1 degree tolerance. Let's see if I can do this one-handed with holding the camera. We're just going to bring it, and it doesn't take a lot to move it. There's 241. It's 2.5 degrees out. That's what I see right there, 2.5 degrees. So we're 2.5 degrees. It's retarded because the events are happening later than we want. So we need to loosen this bolt, make a change to our cam gear, and basically wash, rinse, repeat this process until we have this 2.41 millimeters right here occurring at the 0 mark on our degree wheel. I'm going to work to get this camshaft degreed in rather than walk you guys through this process the entire way. Once I have this one on spec, I'll bring you back and I'll tell you what we had to do to change it. You can see that I have everything marked here for where our starting point is. So I should be able to get this done in one dowel pin movement because there's essentially 3 degrees of change by moving this dowel pin one hole here in the cam gear. And it also will change the hole in the camshaft as well. So we're going to make that change, recheck, bring you guys back and confirm that we're on the right number. That if we're 2.5 degrees off now, we have 3 degrees of range here, that tells us we should be able to get this within 0.5 degree by one movement of the dowel pin, which would be ideal. Let's see if it works out like the math tells us it should. Okay, so we moved our dowel pin one hole. You can see where it's one off to the right of our paint mark that we had there. I have my degree wheel stopped. We're just about 0.5 degree before top dead center. We're at 242. So our math was correct. One hole, which is about 3 degrees, put us about 0.5 degree off, which is exactly what we have. I love it when it lines up. So we'll take this all the way to 0 if I can. The Crankshaft's a little notchy, so that's why I overshot it and I only have one hand. Normally I use two hands to steady myself. But you can see that that makes a pretty big movement right there on the gauge. So the fact that we are just that close is excellent. I don't see anything so far that tells us we need to take a cam gear off and change the orientation to the timing belt with the cam gear, because by doing that we can cut our fidelity down to about 1.5 degrees. Half a degree here. It's well within factory specs. It's about as close as we're going to get it with this setup. So let's move everything over and we'll check the exhaust side, see where that falls. If we have to make any adjustments there, maybe we can consider something here on the intake, although I doubt it. Pretty happy with it. So what I will actually do is I like to make at least 3 checks. I need the same number 3 times before I trust it as a valid number. So I'm going to come back through, make sure that this checks out at being 1/2 degree off before top dead center. 2 more times consecutively. If we're good there, we'll swap our gauge over to the exhaust side. We'll make our checks over there, which that side's done a little bit different. So I'll see you guys back over here when our tooling's on the exhaust side. I'll let you know if anything changes here, but I'm pretty confident we're going to be set on this bank 1 intake cam. Here's one of our checks, 241. You can see 1/2 degree. This guy is dialed on. One more check and we should be good to go. All right, we're getting close. Testing all my skills here. 241, 1/2 degree. Looks like, yeah, we just a hair overshot our TDC gauge or our dial indicator, but you can see this thing is dialed on. It's hard to argue with 1/2 degree. Time to check our exhaust. All right, so our intake checked out good 3 times. We're 1/2 degree. So I moved my tooling over to the exhaust cam. We only have 2 lobes. Either one works. You don't have to worry about it. I'm back here on the rear lobe. Same thing. We're trying to do our best to match the angle of the valve and lifter bucket. It's really hard to do, but I try to line everything up the best I can. Got everything mounted. I'll show you how I have it all set up. I will give you a tip. If you do this semi-frequently on different cars, once you find an easy setup to get your tooling set up on there, take pictures of it. So that way, you never know. It might be 3 years before I do another 355, and rather than fussing with trying to figure out how this tool is set up, it's really easy to go back and reference a picture, and then you can just mimic what you did the last time. Saves you some time, makes things quicker. So our exhaust cam measurements are done a little bit differently than the intake cams. Again, this is Ferrari's infinite wisdom. It's just kind of an arbitrary method. You can see that I now have the engine on top dead center overlap, where we're having a little bit of valve movement on both the intake and exhaust valves. Over here at 0. And since we're on overlap, and I was talking about it earlier, our gauge won't show 0. That's normal because of the lack of compression in the cylinder. And I have this dial gauge zeroed out. Because what we're going to be doing is we're going to be rotating this engine past top dead center. And what it's going to be doing is we're going to be watching, if I have you in here, you're going to see the exhaust cam, the valve is closing. So this is the lobe of the cam. It's going to be rotating counterclockwise up. So the valve's going to come up and close. At a certain point, the valve's going to be fully closed and there's nothing left for this gauge to measure. So what we're effectively doing is measuring the remaining lift on the exhaust camshaft. On the intake cam, where we zeroed our dial gauge out, it was on the base circle of the camshaft. So the crankshaft degree doesn't have to be that critical. You just need to be sure you're on the base circle of the cam when you zero that gauge out. Now it's different. Having our degree wheel at the exact top dead center is critical to zero this gauge out, but when we stop our revolution of where we turn the crank to make this measurement, it doesn't really matter, because once the valve closes and stays closed, this gauge isn't going to change. So it's a little bit backwards from the intake to the exhaust. We're going to just get in here, and like I said, I can just rotate the crankshaft. I don't have to stop at a precise point. Obviously, I don't want to rotate it so far that the cam doesn't start opening the exhaust valve again. But the valve is on its way up, the valve is closing, so as I rotate this, you're going to watch that needle increase, and then it stops right there. And it says 247, and you can see we're, well past our range. Actually, if I just rotate this now, you can see there's no change on our gauge, and you can see it's because the cam lobes are up. I'll show you and move them. So it doesn't really matter how far we rotate the crank on the exhaust side. And we can see that we're at 246 and our spec here is 2.29. So we need to come back and kind of do some math and figure out how many degrees out we really are. Now, if we're at 246 and I said 2.29 is our spec, that gives us 0.17 past our spec where we had basically too much lift, if that makes any sense. It's hard for me because I do all this stuff in my head. I've done it for so long to make sure I'm explaining it the way that makes sense for you guys. So we're going to bring it back around, top dead center of overlap. We're going to stop our degree wheel, and you can see that our valve, our gauge is moving, which it should be. Do our best to stop this at 0. We have this dial gauge zeroed back out. Now, since that number that we were reading was larger than what we're looking for, it was like 2.57, we're looking for 2.29, that's telling me that there was more camshaft lift remaining, which is basically telling me my camshaft is retarded in relation to the crankshaft degrees. So I know we're going to need to make a movement in advancing the camshaft. We need to figure out how far we're going to do that. So what my plan is I'm going to rotate the crankshaft until I see 0.27, because that is the approximate difference we had between the measurement we got and the spec that we have. At 0.27, we're going to look at our degree wheel. That should tell us how many degrees that we're off. And the way to verify that is once we get there, I can get to 0.27 on this gauge, zero this gauge, and then zero it off of top dead center and then rotate it. And if we end up with 2.29, that's the way to verify our math. So you're basically taking the number you got, subtract the spec, and then whatever that equals to, we're going to look for that number on the gauge right now and then read our degree wheel. For the sake of talking, we said 0.27, so that's what we're going to shoot for here. It's hard to be precise holding a camera with one hand doing this. 2.6, that's close enough. I don't want to overshoot it. We're going to come down here, 1, 2. It's a little over 3 degrees. Okay. This is what I was saying is we'll come back and verify that. So if 3 degrees we're off, if we zero that now, this should be, we're zeroed at 3 degrees off. So when I rotate this, I should see close the 2.29, which verifies that we're 3 degrees retarded. We'd need to advance the camshaft 3 degrees. So we're going to rotate it. And not quite the exact number, but we're pretty close, which tells you that that's the move we need to make on the exhaust camshaft. So I'm going to go loosen this up a little bit. I'm going to move my dowel pin. I'm going to advance this camshaft 3 degrees, recheck it, see what we have. We made our move on our camshaft. You can see where the old mark was, where our dowel pin now is. We're at 0. Put a little tension on the crankshaft. There we are. We're at 0. Our gauge is zeroed out. If we look at our cam lobes, we're on overlap. So we rotate it till the valve is closed and there's no more movement left. Right there. And we're at 2.19, so we're 0.10 away from spec. So we're close, way closer than we were before. And we still need to come back and do the same method to verify how many crankshaft degrees off we are. So I'm going to bring it all the way back around to overlap. And is what we're going to do is we're actually going to watch this gauge. And since we're 0.10 off, we're going to watch until we hit 0.10 before top dead center. And that's going to tell us how many degrees off we are on the camshaft. The 0.10 is the difference from the reading we have from the spec. So you can see that we're getting close up here. We'll shift our attention to this gauge. 0.10. Right there. We're half a degree off. So although it looks like it's a big deviation numerically from the spec where we're at, once you come and look at your crankshaft degrees, we're again half a degree, which is well within spec. So we're looking pretty good. I will come through and do, just like we did on the intake camshaft, I'll do 2 more checks on the exhaust camshaft, make sure I get the same number. If I do, I know that we're dialed in and it's time to move over the bank 2. And before I do that, I'll just show you guys, it's been hard doing this filming with one hand. And I actually have this bar as I'm rotating the engine, and you can see I'm actually using my leg to press on the bar so that way I can take any shakes out of it and I don't overshoot the engine. So I kind of have my foot propped up, going slow. Normally I have my other hand right here on the crankshaft holding this ratchet to where I can kind of make sure I can go really slow and deliberate movements, because it doesn't take much of a movement because of your leverage out here to get big changes up on your gauges and your degree wheel. I'll do 2 more checks. Everything checks out. I'm gonna move all my tooling up. I'll spare you guys. I'll move it over. I'll check my pointer. I'll do all that off camera. And I'm thinking I might just run through this exhaust side, and just if it's the same thing we're seeing here, we're making small tweaks. I might bring you guys back, and if there's anything super unusual, I'll definitely bring you guys back to show you that. But I'm hopeful that the exhaust or bank 2 is going to go just like this side, where we're making some small quick movements. You can see that it doesn't take a terribly long time. These washers and the van pliers work out fantastic. So things are going good, and so far the bulk of my time has been invested in setting the timing belt tension. Cam timing's going good. We're halfway done though. Let's get the bank 2 and see how well it treats us. Well guys, to be honest with you, I ended up running out of time last night, so I ended up just calling it, went in for the night. So we're back out here today, continuing on with bank 2. I've already gone ahead and taken the liberty. I got my dial gauge reconfigured over here on our intake camshaft. We're using the forward cam lobe right here, or lifter bucket, for our pointer. You can see I moved our TDC gauge over, and I've already gone through, rotated the engine over, calibrated our TDC gauge and pointer on our degree wheel. So we are all set and in really good shape right here. We just finished the exhaust on bank 1. We got to jump back to the intake, so that process is a little bit different. That's usually just what I do by habit, but it would a lot of times be easier if you're doing the intake, then exhaust, and then you jump over here and do the exhaust first, because the process is still fresh in your head on how to check it, because the process changes. But if we recall, for checking the intake camshaft, we have the engine on top dead center on compression, and since we're on the other bank of the engine, our cam lobes are going to be pointing at a different direction as they are on bank 1, but we're on the base circle of both cam lobes, meaning we're on compression. We're going to have some of our cam lobes pushing down on our valves on overlap. So we're on top dead center compression. We zero out our dial gauge, and then we're going to rotate the engine over to top dead center overlap. We're going to stop precisely at 0. We're going to come back to our gauge, and we are looking for 2.41 millimeters. So once again, I'm going to try to do this one-handed and see if I'm able to get it for you. And you can see, since we're on the base circle of the cam, we should see no movement on our dial gauge. That's what you should be expecting. So getting this zeroed out isn't so critical to have it on the top dead center of overlap. It's just really make sure it's zeroed out when you're on the base circle of the cam, meaning our lobe is pointing up. Slow down a little bit, and you can see we're starting to get some movement. So everything's checking out. And we're going to do our best to creep up on the 0 here and not overshoot it. Try to get you guys in best I can. Degree right there, that's right on the money. And we're saying 189, so we're saying this one's way off, which makes sense because when I pulled this apart, come back to our list here on intake, it was saying it was 3 degrees off and 4 degrees off. You can see we were pretty close over here on bank 1. So we should be 3 degrees off. Again, now we're at 189. We need to rotate it and just continue to watch our gauge until we get to the 241. Overshot it just a skosh, and we're coming down, and that's about 4.5, almost 5 degrees off. Quite a ways off. I kind of expected that. That's why it's nice to do the pre-service cam timing checks, because then it kind of helps anticipate what you're going to be doing when you actually go to correct the camshaft timing, because things should, for the most part, line up and be close to one another. All right, so let's talk about correcting this camshaft timing. So we know that we're at the desired number in terms of camshaft rotation, meaning the camshaft is in the location that we want, but the crankshaft is not in the location that we want. The crankshaft is actually, I'd say, 4 degrees past top dead center, meaning the cam timing is delayed in relation to the crankshaft. That's allowing the crankshaft to rotate too far. So if we accelerate when the camshaft is opening, it's going to accelerate when the camshaft closes, which means it's going to close sooner here on a degree wheel and bring it in. So what we're going to be doing is advancing the camshaft timing. Now the crankshaft is rotating clockwise, our camshafts rotate counterclockwise. So we're going to take our camshaft and we should be rotating it counterclockwise. We'll probably start with this one hole on our dowel pin, recheck, see where we end up. That should give us just 3 degrees of movement. which maybe will get us, since that's right at about 4, maybe right at 1, 1.5. We'll get that dialed in, or get that move done, and bring it back, see how close it gets us. All right, so if we can get up in there, should be able to see right there, we moved our dowel pin 1 hole. We're back, top dead center, compression, zeroed out. We'll bring this back around to top dead center overlap, and we'll check our dial gauge and see how close our movement got us to the desired number. There's about 0, and we're at 226, so that got us a lot closer. We're looking for 241, so we're still a little bit retarded. So same thing, we're going to come up here and watch till we get 241. Overshot that just a little, and get you guys in here. I'm sitting at 1.5 degrees right now, but I did overshoot that a little bit. Let's come back around and check this one more time. Okay, we're zeroed. Effectively zero that guy back out on compression. Bring this back around the 0. Right there at the 0 mark. And 228. Which is good because that's consistent with the way we had last time, 226 last time. So this time, see if I can do it without overshooting it. At 241. There we are, 241. And we are 1.5 degrees. So we need to kind of sit back and think about this for a second. So we're 1.5 degrees. If we go one more dowel pin, we're going to overshoot it. So unfortunately, I think what we're looking at over here on this intake camshaft, I ideally need to move it 1.5 degrees, and we mentioned one dowel pin hole here is 3 degrees. I can take this cam gear off, and if I rotate it 2 teeth on the timing belt, it's important that I keep the timing belt in the exact same location on this camshaft gear and the exact same location here on the crankshaft. I'll only pull out the dowel pin, move this 2 teeth, reinstall it, put my dowel pin back in on the closest hole, run through our cam timing. That's going to break our fidelity down to 1.5 degrees, which should allow me to get my camshaft timing right down here on the money at 0. So I think that's what we're going to do over here before we move on and start working the exhaust side. It also means we're going to have to come back and retension our timing belt. So this kind of is what I was talking about earlier. This opens up quite a bit more work because earlier in the video, it took me quite a long time to get the timing belt tension set on the bank 1 side. Bank 2 went pretty quick. I usually will try this without breaking my timing belt tension by getting the pulley off, everything marked, back together. Sometimes it works, sometimes it doesn't. It just matters if it's your day or not. This is where it takes a lot of time when you're really chasing really precise cam timing. It's really, you know, depending on how things go, pretty much an entire day just setting the timing belt tension, running through and checking the cam timing. I'm not going to cover this in a lot of detail. We did this in great detail. I explained how the cam gears work, how the dowel pins work, all of that on our 99 F355 that I keep referencing. So I'm going to spare you guys for that. I'm going to set you guys down. I'm going to focus on making my changes, get everything set back up, and I'll bring you guys back after our changes are done while we're rechecking to confirm that they did what we want. Well, sometimes things just go your way. I was able to get our cam gear moved while maintaining my timing belt tension, which has saved me a whole heap of time. So what I'll do is I'll end up taking a little Sharpie here. So I just make a black Sharpie mark on this lower cam gear and a mark on the belt so I can make sure that this does not slip or move. It's very important that that doesn't happen. Same thing over here. I just make a little mark, reference mark here, and I make another one on the side. I'll give you guys a view right there. Silver Sharpie on the belt, black Sharpie right there in the cam gear. Up here was the silver Sharpie on the belt and our cam gear. So you can see that I moved this mark over 2 teeth. And that's what's going to give me my movement. So I moved the cam gear just on this belt. I had the dowel pin out, obviously. I have the cam actually held in place, the business card, so it didn't move. And then once I had the cam gear back on, I put the dowel pin in whichever hole it fit in, which was closest, which ironically enough was the hole that we started out with over here on the cam gear, although it's in a completely different hole on the cam shaft. If we were to pull this bolt out, we'll see that it's in a radically different location because I rotated the cam gear. So what I'll need to do now is I'm going to go and I need to pop this business card out before I forget, and then we can run back through this cycle and see how much closer we are to the camshaft timing. Now, sometimes you can be radically off because we weren't really precise where we placed the dowel pin. Sometimes you're right on, so we might have to start working ourselves back to the cam timing. But now that we've changed basically the gradient that we're on with the relation of the dowel pin holes here to the timing belt, we should be able to get this dialed in, theoretically, right on the money with zero deviation whatsoever. I'm going to pull a business card, bring you guys back, and we'll make our check. All right, our business card is out, so let's bring this over to top dead center compression. We can check the zero of our gauge. I like it. Back to top dead center overlap. I'm kind of sneaking a peek at our gauge, seeing how close we're going to be. And right there at 0, so we're at 185, so we're going to need to make a change. That's what I was kind of expecting. So we said we're looking for 241. Let's see how many degrees out we are. That right there is saying 3. So ideally this is going to say 6 degrees out. 241. If we look, oof, it is just about 5, almost 5.5, which is close. So same thing, we're going to make a change in our dowel pin, except I'm going to move it 2 holes instead of 1 hole this time, and that's going to bring us very close. It should be right on the 0 mark or within half a degree. So when we make those changes, we'll note where our dowel pin is right now. It's lined up this paint mark. Bring you guys back while we check and see how well we did. All right, so you can see that I moved my dowel pin 2 holes from where it used to be. And I've already gone through and checked our camshaft timing. You can see I overshot it just a hair, but that's not really enough to make a difference what we're looking at here. And on our degree wheel, you can see that we're now getting our desired number before top dead center, but it actually overshot it quite a bit more than I was expecting. And we're dang near at 4 degrees right here. So, you know, we were almost, I think, what was it, 5.5 degrees over there. So 2 holes on this cam gear should have been 6 degrees total, which should have brought me over right around 1 degree. Not sure exactly why they didn't pan out, but that's why we check everything, right? It doesn't really matter what it theoretically should end up doing. Is what matters is what it actually ended up doing and what effect it had and where it ends up. That's the way I like to think of it. I use the degrees that these are supposed to have and the holes for the perimeter around the cam gear and camshaft as a rough guide. What really matters at the end of the day is what actually happens. So since we know we're overshooting it a little bit, we're going to take this dowel pin back out. We're going to move it up 1 hole, so just effectively 1 hole from where we were, go back the other direction. And again, from what I'm seeing right here, I'm 3.5 degrees out, maybe 4 degrees out. That should put us closer to the 1 or 0, which would be in tolerance. But we won't know until we get it changed and moved and rechecked. I'll see you guys back here in a second. All right, we're at top dead center overlap. We're reading 230, which I have a feeling this is going to pan out being within our 1 degree tolerance, if not half a degree. So we're not dead on the money like I was hoping, but we're very close. So we're looking for 241. We're going to rotate it over until we hit 241 and check our degree wheel, which doesn't take very much movement at all. It's actually hard to go slow enough doing this. Small enough movements, 240. Can I get the 1 without overshooting it? There we go, 241. And that has us right there on the 1 degree mark. 241. I was hoping to get it exactly on the 0 point, but I just don't think we're going to have that adjustability here at the cam gear. Now, I have talked about it in other videos, not this video, but there is about, I'd say, a little bit more than a degree of slop that we can get from our dowel pin to our cam gear to our camshaft. Now, normally I don't like loading my camshafts in the advanced position because theoretically they could slide back to the retarded position as the engine's running. That's just the direction they're going to want to be in because the belt's pulling on them. But let's just see, for just experimenting here, if we loosen this bolt and I'll put my wrench on my cam, leave the dowel pin in its position, rotate the camshaft as advanced as I can get, what number we end up getting here on the degree wheel, and see if we can dial that in exactly to 0 or not. And is really what that's going to tell us is if we're able to hit that exact 0 by doing that, that we're not going to be able to make any other changes to get this dialed in any better than it's at, because the slop is why we're getting a little bit of deviation from what numbers we're getting on the degree wheel to what mathematically we should be getting here, because obviously the math is accounting for perfect tolerances, and I can tell you it's not perfect. So I'm going to make that change, and we'll make one more check. Look at that. On the 0 mark, 241, nailed it. Our dowel pin, it's in the exact same location. So I was able to get that degree out of it just by loosening this bolt. I put my wrench over here on the cam lobes, and I advanced the camshaft, meaning I rotated the camshaft this way since they rotate counterclockwise without moving anything. So if I loosen just this bolt, I can slide everything, and it's just taking up the clearance of the gap in between this dowel pin and its cam gear and the camshaft. So that's as close as we're going to get it right there. Obviously for reassembly, I'm going to assemble this with this camshaft in the advanced position. I don't like to do that, but I do know that if it's in the full retarded position, it's going to be 1 degree out, so that's not detrimental. So if it changes while running, not a big deal, but if we can, we want to have this exactly dialed on right there at the 0 mark. It's not my preferred method to do it, but that's how we're going to do it on this one. It's the only way we can get it dialed in, but either way, if we have the slop accounted for in either direction of the camshaft, it's still within spec on our intake camshaft. So we have 3 down now, 1 more to go. Move our tooling over to the exhaust camshaft, and hopefully this one treats us a little bit better and we can get it knocked out of here real quick. Okay, so we're set up on the exhaust side. You can see I have all my tooling in there. We're on the rear lifter bucket. Again, exhaust cam doesn't matter. I just went for the ease of setup on that. We have our gauge zeroed out. We are on overlap right up on top dead center. So we're measuring the remaining lift on the valve. So if we look, the cam lobe is actually pressing down the exhaust valve right now. And as I rotate the engine, the lobe is going to come up, the exhaust valve is going to close, and we're effectively measuring the remaining lift that is going to be on that. And we're looking for 2.29 millimeters. We just rotate the engine over until our movement stops, and we're at 2.85. So that's given us what? 56.56 away. Since we have a larger number, we had more lift remaining on the camshaft. Let's see how far off we are. I said it was what, about 0.56. We'll bring this back around to top dead center overlap. Again, we're just bypassing the charts that are in the workshop manual because we're here. It's in front of us. We can figure it out without a chart. So we're going to carefully bring this up to 0. Excellent. We're going to ignore the 0.01. That's not going to affect us right here, but we're at 0. But now we're going to turn our attention to this gauge, and we're just going to rotate it till it says the 0.56, which is roughly the difference from our measured value and the spec. 55. If I can get it. I'm so close I don't want to overshoot it. There we go. Yeah. 5.7. I guess at the 0.1 we had there, that gets us there. So we'll come to our degree wheel, and there we have it. 6 degrees, which is about the same that we had over here on our intake camshaft, meaning, again, theoretically, if we move our dowel pin 2 holes, that should give us the 6 degrees. Each hole's 3 degrees, and that should put us right on spec. So that's going to be the move that we make. It didn't work out for us on the intake, but we'll try it on the exhaust and see if we can get this dowel pin moved 2 holes, retard the exhaust camshaft timing, bring you guys back, we'll recheck, remeasure, and see how we did. Okay, so we made our change. You can see the dowel pin there. Moved it 2 holes, and it went counterclockwise if we're talking about in relation to where it was on the cam gear here. I have the engine. It was sitting right back on top dead center overlap right there. I just put a little pressure on my ratchet to get it back right on the money. And I've not done anything with our gauge, and you can see now that the number did not zero out like before, and that's reflecting of the change that we made on our camshaft. So we're going to need to come back and re-zero that back out. We are on overlap, meaning our exhaust valve is closing. We can see our lobes are down. We're at 0, so we're just going to measure the remaining lift. 216. So we overshot our 2.29. I did set this cam gear in the most retarded position like I talked about. That's my default with the slop for the dowel pin. So let's bring this around and see how far a 2.16 actually has us out of spec. That should be 0.13 is our difference from what the factory's calling out. So is what I'm gonna do now, since our number is below, is I'm gonna stop 0.13 before. So we're gonna watch our gauge, and we're not gonna do any zeroing. We're gonna stop it at 0.13. All right, we missed it just a little bit. Oof, look at that. That puts us right on the money this time. Just trying to put a little pressure on it and it overshot. We'll do it again. 1.2, 1.4, I pretty much just had it. And man, that's showing half a degree off. And I tried to rotate it right to 0 again, but I overshot it. Let's just do one more check. We'll stop right at 0, but this is telling us 3 times already that we're essentially in spec. We're going to bring it around again. Stop our degree wheel on 0. Right there. We're at 0.02. Let me see if I can set you guys down in. Set that back to 0. All right, we got that set. How much is left? 218. So we're 0.1 off. Looking pretty good. We could always jump back if you really wanted to and reference the chart and the workshop manual, but I'm pretty confident that we got it dialed in. We'll bring it up right here and just kind of slow it down before we get the top dead center. Watch our gauge reading again. I mean, 0.10 is pretty much on the money. So close. There we go. 10. I mean, that's almost just dead nuts on. We're just, what, a quarter of a degree off? We have our camshaft in our optimal position, which is the most retarded that it could be, which is what we want, like I said, because if that cam ever wants to move out of that position, that's the position it wants to end up in, meaning even if that bolt was slightly loose, the cam's going to end up right where it's at. We're in spec. So I wanted to elaborate on that for a second with the slop and the dowel pin to the camshafts to the cam gears. I will use that slop to perfect my camshaft timing, meaning if the cam's all the way in the retarded position and I'm within spec, I will then, if I can, advance the cam to perfect the spec. I will not use that slop to take a camshaft that's out of spec and then move it into spec. I do that, again, because my thinking is if anything was ever to shift, the camshaft then could fall back out of spec, and that's not what we want. We want the camshaft to always be within spec. So where we are in our exhaust camshaft, it's all the way in the retarded position. We're so close, maybe I can move it just a little and get it dead nuts on, but it's so minor on that one, we're just going to leave it where it's at. I think the intake on bank 2 is the better example to where it was really like 1 degree out and I was able to advance the camshaft and got it dead nuts on the money. So that's an example where I will use that play that's in the hardware for the dowel pin to my advantage. But let's say that camshaft was 2 degrees out and I had to advance the camshaft all the way up to the end stop of the dowel pin and then I'm 1 degree within spec. That's a no-go for me. We're too far out of spec because the camshaft then could fall back out to 2 degrees out. I don't do that. I only do it in the case that we did on the intake cam where I'm perfecting the spec, getting it dead nuts on the money. You can see that's what we ended up with, and I still need to pull these bolts out and get our washers and the O-rings replaced, and that's going to let us see where our existing marks were from where we ended up moving those dowel pins. So I'm going to get those knocked out real quick so I can show you just the difference from where the dowel pins were when we started to where we ended up. And it's just another point that I like to bring up in all my videos. That's why I don't like to engrave these. That's why I don't like to leave any permanent marks. And it's why I clean up all my old marks, because we'll see how far they are off from where they came in. And who knows, even this side, we ended up moving the cam timing, even though it was arguably dang near in spec when it came in. So I'll pop these off real quick so I can show you, and yeah, get this stuff cleaned up, get them torqued down. All right, here we are on bank 2 on the intake camshaft, and you can see that I actually have the dowel pin in the same hole on the camshaft by that mark up there, but it's one hole off on the cam gear. We're able to do so because this is the cam gear that we moved on the timing belt. Otherwise, when you move these dowel pins without moving the cam gear in the timing belt, it moves the dowel pin in the hole of the cam gear and the camshaft. So you can see the changes. I'll show you guys the exhaust side here in a second once I get this one buttoned up. Okay, and we can see here on the exhaust side where our original dowel pin was at in the camshaft and the cam gear, and you can see that we moved it 2 holes here. So you can see how that side was different than it was over here on the intake side because we did not move this cam gear in relation to the timing belt. We only made changes with the dowel pin, and that just is a good reflection or example to show that when you move this dowel pin, you move it over one hole and it goes into a different hole in the camshaft itself. You can see I got everything cleaned up over here, all my marks off, all the paint marks off. I'm going to do the same thing here, clean those off, get it all cleaned up. We have new O-rings going on. We're going to swap out our test washers for these ones that lock in our dowel pins. I'll work to get everything torqued, buttoned up, get all my tooling off, and we are past the big hurdle of getting our cam timing set on this 355. Well, here's our final result. We have all the tooling off the engine. Everything is torqued to spec. You can see I've torque striped it. And I did have to put my business cards back in on my camshaft so that way I could torque down my camshaft gears. So I've removed the business cards and I've gone through and I've torqued every camshaft journal cap, whether I touched it or not, because I just want to be sure that before I put that cam cover on, everything in there is torqued to specifications. Now for torques, torque these cam gear bolts to 100 Newton meters. Again, we put brand new O-rings on the back side. Make sure that the flats of the washers are sitting over your dowel pins. You can feel that as you tighten this bolt in. You can rotate that washer and you'll feel it hit both stops. You can also get in there with a flashlight and make sure it's where it needs to be. Tensioner bearings, torque to 70 Newton meters. Down here, 70 Newton meters. And I talked about it when we're setting our timing belt tension. I leave my pins in the entire time. It's just a good, quick sanity check that, yep, they move. Our timing belts are still roughly where they need to be tensioned, because these basically, they'll still move when you're in the tensioner and give you a gross range, meaning a pretty big margin of where the tension is actually at. With that frequency gauge, it dials it in and it's much more precise. So just because these are still moving in there doesn't mean it's at the exact same tension I set them at since I used the frequency gauge. I have double checked it, so I know that they are. So we are set. I'll bring you guys over to my sheet here. We can see that this car came in with a camshaft 1.5 degrees out, which isn't too bad at all considering the mileage and use of this car. This camshaft on bank 1, the exhaust was 1 degree out. That's within spec. The intake and exhaust on bank 2, 3 degrees out and 4 degrees out. So quite a bit. Here's what we ended up with. Bank 1, both camshafts, only 0.5 degree out from spec. But look at this. Bank 2, both camshafts, exactly on spec. We got them on the money. And I will say that a car that's had the timing belts degreed in and had a fair amount of miles and use on the car, it's not unusual for them to come in like we had on bank 1 where they're a degree and a half out. Totally not unusual at all. I mean, honestly, it's not unusual to find them when they're out like we had on the exhaust side. Obviously, since those are 3 and 4 degrees out, we had to make more and bigger movements to get our cams dialed back in, but we got them dead nuts on the money. Everything turned out nice, and this was really the big slowdown of this process, because obviously you guys saw in this video, it takes a pretty good investment in time to get the timing belts tensioned and get the camshafts agreed and then run through this process. It's not necessarily a super quick endeavor, especially if you're trying to be as precise as possible. But now that that's done, it always feels like it's just downhill from here. The rest of the stuff on this car is going to go together a lot quicker, be back together a lot quicker, and it's just going to feel like we're getting some momentum on our side, like we're running downhill from this point forward. Well, I hope you guys enjoyed following along as we tore down the engine on this 355, replaced our timing belts, worked to retension them, and I walked you guys through a quick version of the process to degree in our camshafts. We did get the timing belts installed and replaced, and most people refer to this service as a timing belt service, but truth be told, I still have a ton of work ahead of me. I have a lot of loose odds and ends, and there is really a lot more that we do to these cars than just the timing belts during the timing belt service. The reason why I say this is because you guys are going to want to jump in and check out the next video we're going to have here on the channel, because I'm going to bring you guys along and show you all those odds and ends, extra services, checks, things that we replace, all those small items that I do additional to our timing belts during the timing belt service to be sure that this car is fully sorted and ready for the open road. Now, I do want to give a special shout out to those of you that have joined the channel membership. I greatly appreciate the support. It does mean a lot to me. As for the rest of you, you guys know the drill. Be sure to like, share, drop a comment below. If you're not subscribed to the channel, you definitely need to subscribe now. As always, guys, thanks for watching. Appreciate your support, and we'll see you on the next one.